Welcome back everyone to part 6 of this sample lab series. So we're getting down to the end and we need to add IP addresses for the router to router connections. So that would mean for LAN 5, LAN 6, LAN 7, LAN 8, and LAN 9. We know that if we want to be efficient about our IP usage, that all we would need is a total of 4 IP addresses for each of these segments, which is 2 usable IP addresses plus the network name and the broadcast IP. So that's a total of 4. How do we break an IP address down into segments of 4? Well, we know that if we borrow bits and the remaining zeros that's left determines the number of IP addresses, then what we could do is borrow enough bits so that we only have two to the 2 remaining. So that would mean that we borrow 1, 2, 3, 4, 5, 6 bits, 7, 8, leaving 2 remaining zeros. So in this case, what would happen is the 2 to the 6 will represent the 2 to the 6 will represent the number of segments that you could break up an IP address into, and 2 to the 6 is 64. The number of zeros, however, tells you the number of actual usable IP addresses you get within each segment. So 2 to the 2 gives you 4 usable IP addresses. And that's what we need for all these segments that we're going to be doing. Once we have 2 to the 4, then what we also need to do is to create a subnet mask. So that's not create the subnet mask, but calculate the value of the subnet mask. So it's 255.255.255, and in this case we're going to calculate the subnet mask as we did before, which is using the number of usable IP addresses and subtracting that from 256. So 256 minus 4 leaves you with 252, and that is your subnet mask. You could also add up all the values of the ones and you would get the subnet mask as well. So we can do that quickly. So since we borrowed 6 bits, in this case we're going to go with the first bit representing 128 plus the second bit, which is 64, plus the third bit, which is 32, plus the fourth bit, which is 16, plus the fifth bit, which is 8, plus the sixth bit, which is 4. Enter. Oh, why am I off? I'm missing something. Let's do that again. So 156 minus 4 equals to 152. And the other way to do it is to say 128 plus 64 plus 32 plus 16 plus 8 plus 4 equals 252. Why was I off before? I don't know. I'll watch the video again and figure out what I did wrong. But again, as long as you add the value up of each of these ones, you should get the digits for the last octet of your subnet mask. Or you could take the number of usable IP addresses, which is 4, and subtract that from 256, which is the maximum number of usable IPs. Okay, let's move on. So now that we have the value of our subnet mask, we could move on to assigning that value to one of our segments. Or let's just break down the first block of IP addresses. So we know this is 16 IP addresses, And if we're dividing them into 4, we should be able to get 4 blocks just using this first set of 16 that goes from 208 to 223. Okay, and so as we do that, that becomes 192.168.1.208, and that is going to go to 192.168.1.211 because we're only adding 3 more to get a total of 4 IP addresses. Okay, so 192.168.1.12 is going to be our starting IP address for the second block, 212, and that is going to go all the way up to 192.168.215, and that is a second block of 4. Continuing on, 192.168.1.216 is going to be the first, and that's going to go to 192.168.1.219, and that is your third block of 4 IP addresses. And finally, you're going to go 192.168.220, and that's going to go to 192.168.223. Okay, so that with that, we've split up our first block of 16 into 4 usable 4 blocks of IP addresses, and we still have this block of IP addresses, this 192.168, a block of 32, which is still usable. So these are our usable IP addresses. We haven't assigned them yet, so what we're going to do is to assign these 1, 2, 3, 4 segments to the first 4. So 1, 2, 3, 4. So let's do that quickly. So LAN 5, you will get your IP address would be 192.168.1.208 all the way up to 192.168.1.211, and your subnet mask would be 255.255.255.252, and that should be it for you. Very good. I'm liking that right there. Now LAN 6 would be very similar, so you'll get the second block of IP address. So you get 192.168.1.208, and that ranges from 208 to 192.168.1.215, and that is a block of 4 IP addresses. So we already have that information, and your subnet mask will be 255.255.255.252. Okay, so that looks awesome. I'm liking that a lot. So that's your second block of IP addresses. Your third block of IP addresses for LAN 7 would be as follows: 192.168.1.216, and that goes from 192.168.1.219, and the subnet mask is 255.255.255.252. Okay, that would make up LAN 7, and LAN 8 requires another 4 IP addresses, and it so happens that we have final block of 4 IP addresses, which is 192.168.1.220, and that goes to 192.168.1.223. Subnet mask 255.255.255.252. Okay, so we are almost complete with all our IP addresses except for this last and final LAN. But lucky for us, we still have this block of 32 IP addresses to work with. So we're going to come over here and we're going to store this over here so that when we come back in our next video, we'll be able to use this 32 block of IP addresses, break it down into blocks of 4 IP addresses, and assign one of those 4 blocks over here for this LAN 9 here. All right, so I will see you in the other video. Thank you for watching. Thank you.